All right, welcome to the Deep Dive. Today, we're going to try to get to the bottom of something, something that's really at the core of how computers, well, how they think, I guess you could say, or how they make decisions. It's called selection. I guess think of it as the logic, the underlying logic that lets our devices and our technology, all the things we use, react differently in different situations, right?
Mm-hmm.
So it's basically the if this, then that kind of thing, which that powers so much of what we use every single day.
Yeah, absolutely. It's that core decision-making process, and to really understand how it works.
Yep.
We've been delving into some super clear explanations over on the Code Curious YouTube channel. In particular, these videos, they're titled APCSP361 Conditionals, APCSP362 Conditionals, and then APCSP363 Conditionals.
Okay.
And these videos do a fantastic job of breaking down these things called conditionals, which sometimes you might hear them called if statements too, but they're the same thing.
Okay.
So they're really the key to this whole idea of selection.
Right. So essentially what we're trying to do in this deep dive today is to really grasp how these if statements, these conditionals, how they actually give algorithms the power to produce different outcomes depending on certain conditions.
Yeah, absolutely. It's about understanding how they make those choices.
Right. And we really want to make this easy to understand for everyone, this core concept in computer science, which honestly is more important than ever these days.
Oh, absolutely, yeah.
So let's jump right in. First things first, what exactly is selection when we're talking about algorithms? I mean, what are we even dealing with here?
Well, let's break it down, starting with the basics. An algorithm at its core is really just a set of instructions. It's like a recipe. Yeah. It's designed to achieve a specific goal, to solve a problem. Now, you build these algorithms using a few key components. One is sequencing, which is simply, instructions happening one after another in order.
Okay, so like step 1, step 2, step 3.
Exactly, yeah. Then there's iteration, which is basically repeating certain instructions multiple times. You do something over and over.
Gotcha.
And then finally, we get to our star of the show, selection.
Okay.
This is where it gets interesting.
All right, so I'm thinking sequencing is like, following those assembly instructions for putting together furniture, right?
Yeah, exactly.
One step at a time. And then iteration is like, I don't know, tighten the screw, but you do it 6 times until it's really in there.
Perfect analogy.
Okay, good. Glad I got those. So where does selection fit it? Is it like if you're using a Phillips head screwdriver, use this step, but if you're using a flathead, do that step?
You nailed it. That's exactly what selection is all about. It's the part of the algorithm that allows it to, choose between different paths, outcomes, based on whether a condition is true or false. It's a simple yes or no.
True or false. Yeah.
That's it.
Okay, so it boils down to this binary decision, true or false, and that determines what the algorithm does next.
Exactly. That's how it navigates the instructions.
And you were saying before, this whole idea, this true or false thing, it's part of what's called computational thinking, right?
Absolutely. It's a fundamental skill. Even if you're not a programmer, even if you never write a single line of code.
So it's a good way to think about things even outside of the computer world.
It is, because once you get selection, you start to see how to break down complex problems into these series of yes or no decisions.
Oh, okay, that makes sense.
And that kind of thinking can be super valuable, in all sorts of situations.
So it's really about problem solving in general, right?
Yeah, it's a framework for approaching problems.
All right, cool. So we got the foundation laid. Now let's dive into some, real world examples of selection in action. You mentioned those Code Curious videos.
Yeah.
They had some really good illustrations. What was that first one? The number range check?
Oh yeah, the number range check. That's a classic example. It's a basic concept, but it pops up everywhere.
Okay.
So what this algorithm does is it checks if a number that a user types in or enters falls within a certain range. In this case, the range was greater than 0, but also less than 10.
Oh, so there are actually the 2 conditions there.
Yeah, exactly. It's like a double check.
Gotcha. So both of those conditions, the greater than 0 and less than 10, they both have to be true for the whole thing to be true.
You got it. It's an A and D situation.
Okay, so what happens next?
Well, if both conditions are met, if it's a yes to both, then the algorithm goes ahead and displays the number.
Okay.
But if either condition is false, meaning the number is, 0, negative, 10, anything outside of that range, the algorithm just says goodbye.
Just goodbye.
That's it.
So that's all based on whether the condition is true or false.
Exactly. It's all about that evaluation.
Okay. So a simple example, but it shows how this true or false thing actually works in practice.
Right, and you see this kind of check all the time online.
Oh, yeah, like when you have to enter your age or something.
Exactly. Websites use it to make sure you're entering valid information.
Makes sense, makes sense.
Prevents errors, keeps things running smoothly.
All right, that was a good one.
Hey.
What's the next example? I think it has something to do with high scores in a game, right?
Yes. So imagine you're playing a game, and we want to keep track of the highest score anyone has achieved so far.
Okay, yeah, that's pretty common.
The algorithm would start with an initial high score. Let's say it's 10 to begin with.
Right.
Then, when someone plays, it gets their score.
Okay.
And here's where selection comes in. The algorithm asks, is this current score greater than the high score we've got stored?
So another yes or no question.
Exactly. It's always about that true or false decision.
Okay.
Now, if the answer is yes, if the current score is indeed higher, then the algorithm updates the high score to this new value.
Okay.
But if the answer is no, meaning the current score is not higher than the stored one, then the algorithm just keeps the existing high score. It doesn't change anything.
So it's like update if there's a new champion, otherwise keep the reigning champ.
Precisely. It's all about recognizing and responding to that key condition.
I like it. And this is how programs can remember stuff, right? Like it's part of their memory in a way.
Absolutely. It's a basic form of what we call state management, how a program keeps track of information.
Makes perfect sense.
Yeah.
All right, what was the next example? I think there was one with students, grades, and extra credit.
Oh, yeah, that one. So there, it was all about whether a student's average grade made them eligible for extra credit. And they used a flow chart to illustrate the process, which can be really helpful.
Yeah, flowcharts are good for visualizing things.
Definitely. So the algorithm looks at the student's average grade and asks, is this average grade at least 75?
Okay, another clear yes or no.
Right. If the answer is yes, meaning their grade is 75 or higher, then they qualify for the extra credit.
Awesome for them.
But if the average grade is below 75, meaning the condition is false, then they have to attend tutoring.
Oh, bummer. So different outcomes based on that one condition.
Precisely. It's like a fork in the road.
Yeah.
But here's the interesting part. Regardless of whether they get extra credit or go to tutoring, the algorithm always ends with the message, have a good day.
Oh, okay. So it's like two different paths, but they kind of merge back together at the end.
Exactly. It demonstrates how selection creates those branching paths, but they can still converge later on.
Makes sense. And this kind of logic, it's probably used in like school software systems, right?
All the time. It helps manage student progress automatically.
Pretty cool. So different consequences based on the grade, but a common concluding message.
Yeah, that sums it up well.
And the last example, I think it had something to do with multiples of 3, right? Like figuring out if a number is divisible by 3.
You got it. This one's a bit more mathy, but it still relies on that core selection principle. So the algorithm takes a positive number as input, and the question is this number perfectly divisible by 3?
Okay, so how do you determine that?
They use something called the mod operator for this.
Mod. Okay.
It's a little tricky, but think of it as finding the remainder after you divide.
Yeah, the leftover.
Exactly. So the condition becomes, does number mod 3 equal 0? If there's no remainder when you divide by 3, then it's a multiple of 3.
Okay, I'm following.
So if that condition is true, the algorithm says multiple of 3. If it's false, it says not a multiple of 3. Again, a clear decision point based on true or false.
So it's still that same basic pattern.
Yeah,
Evaluate the condition, then choose the appropriate action.
exactly. It highlights how even simple tasks rely on these conditional checks. And trust me, these divisibility checks get used in all sorts of more complex algorithms.
Okay, so it's not just for checking multiples of 3 then?
No, not at all. They're used in things like cryptography, pattern recognition, all sorts of things.
Wow. All right, I'm starting to see how this all fits together.
Yeah, it's really fascinating when you start to see the connections.
All right, so those examples were really helpful for seeing how selection works in different scenarios, like the decision-making part of an algorithm. Now, you mentioned another video that talked about how these ideas are actually put into code, like the actual instructions that computers understand, using something called if statements. Can you break that down for us?
Yeah, absolutely. So these if statements, or sometimes you'll hear them called conditional statements, are the programmer's tools for bringing selection to life within the code. They're the way we tell a computer to make those true or false decisions. The simplest form is the basic if statement. It looks something like this. If condition, do these statements.
Okay.
Now, here's the important part. The code inside those curly braces or sometimes it's a block in a visual programming language, that code only runs if the condition inside the parentheses is true. If it's false, the computer completely ignores that whole chunk of code, just skips right over it.
Oh, so it's like a path that's only open if you have the right key.
Perfect analogy. That's exactly it.
All right, cool.
So the parentheses hold the question, and the curly braces hold the answer, or rather, what to do if the answer is yes.
Okay, that's a good way to think about it.
Yeah.
But what happens when you have two possible outcomes, like in that multiples of 3 example? You know, one message for yes and a different one for no.
Yeah, that's where we bring in the if-else statement.
If else.
It builds on the basic if statement, so it looks like this. If condition, do these statements if true, else do these statements if false.
Okay, so it's like an either situation.
Exactly. If the condition is true, the code in the if block runs. If the condition is false, the computer jumps down to the else block and runs that code instead.
So one of those two sets of instructions will always happen, but never both at the same time.
That's the key. It ensures that only one path is taken.
Makes sense. It's like choosing between 2 doors and you can only go through one.
Exactly. And this is what gives programs that flexibility to handle all sorts of different scenarios.
Yeah, because in the real world, things aren't always just yes or no, right?
Yeah. Right. There are often multiple possibilities.
Now, I remember one of the videos used that number range example from before to show a basic if statement in code.
Yeah, that's right. So the program would get the user's number, store it in a variable, let's just call it number for simplicity.
Okay.
Then it would have that if statement checking is number greater than 0 and D number is less than 10.
The double condition again.
Yeah. And if that was true, then the code inside the if block would display the value of number. But the instruction to display goodbye, that was actually outside the if block.
Oh, so that would happen no matter what.
Exactly. It would always execute, regardless of whether the number was in the range or not. It shows how only the code inside the if block is conditional.
Okay, so it's like a default action that happens unless the if condition changes things. That's a good way to put it. And then the multiple of 3 check.
Yeah.
That one showed the if-else structure in action, right?
Right. So the code would first check, does number mod 3 equal 0? If that was true, the if part would display multiple of 3. But if it was false, the program would skip to the else part and display not a multiple of 3.
So 2 clear possibilities, and the code picks the right one based on the condition.
That's how it works.
And I remember there was also that practice exercise where you had to calculate the sum of 2 numbers and then do something based on whether the sum was bigger than 100.
Oh yeah, that was a good one. It really demonstrates how if else gets used in practice. So you take 2 numbers, add them up, and then check, is the sum greater than 100? If it is, you display the number 100. But if it's not, you display the actual sum that you calculated. So classic if-else scenario.
Yeah. Okay, so the condition is sum greater than 100. If yes, show 100. If no, show the actual sum.
Exactly. It's all about controlling what the program does based on those calculations and comparisons.
So if gives you one possible path, and if else lets you choose between 2.
Yeah, that's a good way to summarize it.
All right, now, I think the last video in this series talked about actually figuring out what will happen when you run code that has these if and if-else statements. How do we do that? It seems like it could get complicated.
It can seem that way, but the basic principle is actually pretty simple. Code, even with these conditional statements, usually runs one line at a time from top to bottom.
Oh, like reading a book.
Exactly. And when the program hits an if or an if-else statement, the first thing it does is check that condition inside the parentheses. And based on whether that's true or false, it decides which block of code to run.
Okay, so true goes one way, false goes another way.
Right. If it's true, it runs the if block. If it's false and there's an else, it runs the else block. But if it's false and there's no else, it just skips the if block entirely and moves on to the next line.
So it's like check the condition, make the decision, then execute the appropriate instructions.
That's the flow. And this step-by-step thinking, it's crucial for understanding how any program works, especially if you're trying to fix errors.
Yeah, debugging.
Yeah, you got to be able to trace the logic.
So to figure out what a program will do, we have to go through the code line by line, keep track of the values of the variables, and evaluate those conditions as we come to them.
Exactly. You got to follow the program's thought process, so to speak.
All right, I think I can handle that. Now, the video had some good examples for how to do this. What was that first one? I had like 3 variables, I think.
Yeah, that's right. They set up 3 variables. Num1 was 12, num2 was 31, and num3 was 28. Then came the if statement. If num1, num3.
Okay, so we got to check that condition. Is 12 greater than 28?
Well, no, it's not. So that condition is false.
False. So what happens next?
Since it's false, the program completely ignores the code inside the if block and jumps straight to the else block.
Okay, it takes the detour.
Exactly. And inside the else block, there's the instruction. Num1, angle 3, 2, 4.
Okay, bit of math there.
Yeah, so you got to calculate that. Num3 is 28, times 2 is 56, divided by 4 is 14. So now num1 is 14.
So the else changed the value of num1. It did. And then the last step in that example was to display the values of all three variables. So you would see 14, 31, and 28.
All right, so the else gave an alternative set of instructions when the if condition wasn't met.
Yeah, that's the purpose of else. It provides a backup plan.
And that second example, it had a few more operations, right? Like that mod thing again?
Yeah, that one was a bit more involved. It started by setting num1 to 55.
Okay.
Then it calculated num2 using the modulo operator. Num2 equals num1 mod 2 plus 10. Now remember, mod gives you the remainder after division.
Yeah, the leftover.
So 55 divided by 2, the remainder is 1. Then add 10, so num2 becomes 11.
All right, got that. What's next?
Then they set num3 to num22, which is 11 times 2, so 22.
Okay, keeping track.
And then we hit that if condition, the one with the or operator.
Yeah, the or thing always throws me off a bit.
It can be tricky. So the condition was if num1 plus num2 20 or num3 10.
Okay, two parts connected by or.
Right. We got to evaluate both. First, is num1 plus num2 greater than 20? Well, 55 plus 11 is 66, which is definitely greater than 20.
True.
True. Now, here's the thing about or. If either part of the condition is true, then the whole thing is true. We don't even need to check the second part.
Oh, so we can stop there.
We can. Because that first part is true, the whole condition is true.
All right, so the program doesn't even bother with the num310 part.
It doesn't need to. It's like a shortcut.
Interesting. So what happens next?
Well, since the whole if condition is true, the code inside the if block runs. And in this case, it was simply the instruction to display you win.
Oh, so that's what the user would see on the screen.
That's the output. This example really shows how important it is to understand all those operators, the greater than, less than, or, and how they all work together.
Yeah, there's definitely a logic to it.
Absolutely. It's all about that logical evaluation.
Going through those examples step by step, it really helps to see how the program flows based on those if statements. It's like you're not just writing instructions, you're creating a decision-making path for the computer to follow.
Exactly. It's like you're designing the computer's thought process.
Okay, so big picture time. What are the key takeaways here about selection and all these conditional statements?
The main point is that selection, which is brought to life through those if and if-else statements in the code, it's what gives algorithms and programs the power to be dynamic and adaptable.
Dynamic, adaptable.
Yeah, so they can react differently based on the input they receive, the data they're working with, the situation at hand. It's what makes software seem smart.
Oh, like you can actually make choices.
Exactly, and it's how programs can handle such a wide range of tasks and scenarios.
So everything from those simple checks, like making sure you typed your email correctly,
Yeah.
to super complex stuff like AI.
Yeah, it all boils down to these if this, then that decisions.
It's kind of amazing when you think about it. And for our listeners, I mean, understanding this concept, it really helps to demystify how technology works.
Yeah.
It's not just some magical black box.
Right, it's not magic.
It's a series of logical choices based on those true or false evaluations that we've been talking about.
Exactly. And hopefully, with these examples from Code Curious, we've made this concept, this fundamental concept of computer science, more accessible.
Definitely more clear.
Yeah.
So, as you go about your day, think about all the technology you use, your phone, your computer, your smart devices.
Even things you wouldn't expect, like your car or your thermostat.
And consider how this conditional logic, those if statements, are probably working behind the scenes.
They're everywhere. And it's fascinating when you start to see the patterns.
It is. And here's something to ponder.
Mm-hmm.
If algorithms are basically just these chains of decisions based on true or false, what does that tell us about how the digital world really works?
Yeah, it's a deep question.
It is. And it's something we're thinking about, the implications of this kind of logic being so fundamental to everything around us.
Absolutely. It raises questions about control, bias, the nature of intelligence itself.
Big questions. And I think we'll leave it there for today. Thanks for joining us on the Deep Dive. We'll see you next time.
Thanks for having me. It's been a great conversation.
It has. Always a pleasure.